Can you find the radius of this circle? We are given right trapezoid like this with the top base as 3 units and the bottom base as 5 units. Inside this trapezoid, a circle is placed in such a way that all the sides of the trapezoid are tangent to this circle, and our goal is to find the radius of this circle. You can pause the video and take a moment to think about it, and when you're ready, you can always come back to verify your answer. Alright, let's solve it together. But before we begin, let's define the radius of this circle as r and construct some radii. First, let's draw a radius from the center of the circle to this point of tangency on the vertical side, like this. Since this is a point of contact of tangency, that means according to the tangent perpendicular theorem, this radius is perpendicular to this vertical side, giving us 90-degree angle. Now let's draw a radius to the top side of the trapezoid like this. Again, this is point of tangency. That means this is also 90-degree. Finally, draw a radius to the bottom side of the trapezoid, and this angle will also be 90 degrees. Did you notice something? We've now formed two squares, this one at the top and this one at the bottom of the trapezoid, and the sides of these squares are equal to the radius of the circle. So let's label all of them as r. That means the height of this trapezoid is equal to r plus r, which is 2r. Now focus on this bottom side of the trapezoid. If this side is of r units long, then this remaining part of the bottom base of the trapezoid will have a length of 5 minus r. Likewise, for the top side of the trapezoid, if this is r units, then this remaining length will be of 3 minus r units. Now let's focus on these two tangent segments. We know that, according to the tangents from an external point theorem, when two tangent segments are drawn from a single external point to a circle, they are always equal in length. That means on this bottom side, each tangent segment from this point will be equal to 5 minus r, and on the top side, each tangent segment will be equal to 3 minus r, correct? Now let's draw a perpendicular line, forming a right triangle like this. The height of this right triangle is the same as the height of the trapezoid, which is 2 times r, and the base of this right triangle is the difference between these two bases, that is 5 minus 3, or 2 units. Now let's focus on the right triangle we've constructed. One leg has a length of 2r, and other leg has a length of 2 units. The hypotenuse will be this length, which is the total of 3 minus r plus 5 minus r, which simplifies to 8 minus 2r. Now, using everyone's favorite, the Pythagorean theorem, we get 2 times r squared plus 2 squared is equal to 8 minus 2r squared. Now, simplifying this left-hand side and expanding right-hand side expression using famous algebraic identity of difference, we get 4 times r squared plus 4 is equal to 64 minus 32, r plus 4 times r squared. Subtracting 4 times r squared from both sides, we get 4 equal to 64 minus 32r. Again, subtracting 64 from both sides, we get negative 60 is equal to negative 32r. Now finally dividing both sides by negative 32, we get r is equal to 60 divided by 32, which simplifies to 15 over 8, or in decimal form, 1.875 units. And that's our final answer. Pretty amazing, isn't it? Even though we didn't know the radius at the beginning, a little geometry and algebra helped us find its exact value. But wait, before you go, I have a quick bonus challenge for you. Can you find the area of this circle in terms of two variables, x and y, instead of numbers? Think it through and drop your answer in the comments below. Let's see who can figure it out. If you found this explanation helpful and learned something new, don't forget to hit that like button, share it with a friend, and subscribe for more mind-bending math questions. Thanks for watching, and I'll see you in the next video.